This is the lecture for Chapter 3, Section D, page 7 and 8, and actually it goes on to 9 and 10 also because Section D has two exercise sets. So, for the page 90 reading, this is review of the distributive property and FOIL. Okay, so if you can do these, you don't need to read your book, but let's see. If you want to expand this, you would first multiply a times b, and then you would multiply a times c, and you would add those together. Okay, so that's the distributive property. Okay, and if you do a real example, let's say you have 3 times 8. Is that the same thing as 3 times 5 plus 3? Is that the same thing as 15 plus 9? Yes, they are. Okay, so that's how that works. A plus b times c plus d. You need to just multiply all possible combinations times each other. The way you do that is you multiply a times c, you multiply b times d, you multiply a times d, and you multiply b times c. Okay, and the reason why that's called FOIL is because you're multiplying the two first ones, that's the F, you multiply the two last ones, that's the L, then you multiply the inside terms, that's B and C, the inside terms, I, and then you multiply the outside terms. Actually, it's the other way, right? Otherwise it would be FIOL instead of FOIL. Okay, so you do FOIL, you multiply A times D, you multiply A times C, you multiply B times D. That's the first and the last. Then you multiply the outside terms, AD. Then you multiply the inside terms, BC. And you add all those together. Okay? So the F would be AC, the last would be BD, and the outside term would be AD, and the inside terms would be BC. Okay? Um, okay, now, this one you may remember after I write this down, but this is kind of a special one because when you do FOIL, a squared, and then negative b squared, something happens special when you do the O and the I. When you do the outside terms, it's negative a and b. When you do the inside terms, it's positive a and b. And then when you simplify it, look, negative ab cancels with ab, and you're left with a squared minus b squared. Okay? The SAT loves this too. Okay? Do you know that a squared minus b squared can actually be expanded to be a plus b times a minus b? Okay? A plus b squared. This expands with FOIL to a squared, b squared, and then the inside and the outside terms are both ab. So usually the way we write this is we write plus 2ab. And then when you have a negative b squared, it looks almost the same, except in the outside and inside terms you have negative ab, negative ab. When you combine those, it is negative 2ab. Okay? These are plus. Okay. Now we can move on. Using those rules, we're going to do these exercises. And I'm going to go ahead and do an example from all these chapters. Should I do the hardest one then? I'm assuming it's the last one. Okay. This is pretty tricky. It's you have to multiply this times this, then this times this, then this times this. But that's not the hard part, right? The hard part is what do you do with all these fractional exponents? So the first term is going to be x to the negative 1/2 x squared. And the next term is going to be x to the negative 1/2 times x. And the next term is going to be x to the negative 1/2 times x to the 1/2. And these two together, when you have x to the something times x to the something, you can add the exponents. Well, if you add negative 1/2 to 1/2, you end up with x to 0, which is 1. For this, you have x to the 1 minus 1/2. It doesn't say 1 there, but we can put 1 there because x to the 1 is x. So now you can add the exponents. 1 minus a half is x to the 1/2. And for this one, you have 2 minus a half, so that would be x to the 3/2, right? So that's your answer. X to the 3/2 plus x to the 1/2 plus 1. Okay, let's go to the last one here. Okay, here we're gonna, this looks like an SAT problem. You have a plus and a minus. These are the same, and these are the same. So when you have that, basically you have the pattern a plus b times a minus b, and then you're going to recognize that as simplifying to a squared minus b squared. If you don't recognize it, you can just do FOIL, and eventually you're going to get there because everything's going to cancel out. Okay? So let's say we do recognize it. So then we just need to take these first terms and multiply them together. Well, x to the 1/2 times x to the 1/2, you add the exponents and you get x to the 1. And you do this one. You get negative x to the negative 1/2, x to the negative 1/2, and you add those together and you get x to the negative 1 minus. So now we have x to the 1 minus x to the negative 1. Okay, that's how that simplifies. I guess that wasn't the last one. The last one was this one. Should we do this one too? Here we have the pattern a, we could say a minus b squared, right? A minus b squared, remember, turns into a squared plus, a squared minus 2ab plus b squared. So a squared would be 5 squared, minus 2ab would minus 2 times 5 times 2 to the negative x. And then b squared would be 2 to the negative 2x, right? Because it would be 2 to the negative x squared, 2 to the negative 2x. You can multiply those together, right? 2 to the negative x squared, you can multiply these two together, you get 2 to the negative 2x. Okay? So that's our answer for that. We just need to simplify it. We could make 5 squared into 25. We could make 2 times 5 into 10. 10 times 2 to the negative x. You can't combine these, right? Because this is a constant. This is an exponent. And then plus 2 to the negative 2x. Okay? Let's move on. Now this is the next page. This is not for the next class. It's for the class after that, right? But there's no lecture for this, so I'll go ahead and work on these problems too. You can wait and do these for the next class if you want to. Factorize. So now we're kind of doing the opposite. They've multiplied everything out. We're going to go backwards. We're going to try to use the distributive property. The distributive property, remember, if you have AB plus AC, you can factor out the A and you can get B, leave B's plus C in the middle. Okay? So it's kind of like that. So here, what's the common factor between these two? I think 5 to the x, right? So 5 to the x out of 5 to the x is 1. Now this one's the hard one. What's that? That's actually 5 to the x squared, right? So if I factor out a 5 to the x, what's left is a 5 to the x. Okay? Oops, I did the first one instead of the last one. Okay, now this one, we can recognize that minus 16 is actually 4 squared, right? So the common factor here is 4 squared. So we'll take out 4 squared, and then 4 to the n plus 1, remember, is 4 to the n times 4 squared. So if we factor out 4 squared, what's left is 4 to the n. Okay? Now let's go to the last one here. For this one, they want you to recognize that this is actually a squared minus 2ab plus b squared. Okay? So this can be factored into a plus b squared. Okay? So if this is a squared, a would be, let's see, 25 is equal to 5 squared to the x. So that would be 5 to the 2x. So if I was going to take the, let me write that in a more simple way, 5x squared. Okay? So if a squared is 5x squared, then a would be 5x. Okay, and then plus 4. If 4 is b squared, then that means b is 2. And then since, oh, I'm sorry, I made a mistake here. It should be a minus b. A minus b. So this would be 5x minus 2 squared. Okay, let's just test out if the middle works. So the outside-inside part would be 2 times 5x, and then I would need to double it, right? Negative 2 to the 2 5x. So that would be 4 5x. Yes, so that would be negative 2ab would be negative 2 times 5 of x times 2, which is equal to negative 4 times 5x, and that's what is right there, right? So yes, this is correct. Okay, moving on. Number 3, we'll do the last one. Okay, on this one, this is not going to be a perfect square. So this is just a regular painful factoring problem where you were going to say, okay, well, I got a plus b times, c plus d. Okay, so you have like two different binomials multiplied times each other, and you try to figure out how they factor out. Well, in this case, we're fortunate to have at least the first term the same, a. Okay, so the 49x is, we can see that 49x is actually 7 squared to the x, right? So when we factor 7 to the 2x into two binomials, we're going to put 7x for the first terms. And for the last terms, we're going to put probably like 3 and 4, or 2 and 6, or 1 and 12. Looks like to get a 7 there, the best bet would be to put a 3 and a 4. Okay, because 3 and 4 add up to 7, right? And I put negatives on both because I need to multiply them together and get a 12, but I need to add the outside and inside terms to get a negative. So these are going to be negative. And if you're shaky on factoring and you want to not be shaky anymore, then come to Homework Club and I'll help you there. So this looks like it works out. When I do the inside terms, it gives me negative 3 7x. And when I do the outside terms, I get negative 4 times 7x. And then if I add those together, I get negative 7 times 7x, which would be the same as negative 7x plus 1. And that's what they got, right? So that works out. Okay. Last one here. 5 to the n plus 1 divided by 5. Okay, so what we do here is we'll put the 5 in the denominator upstairs, and we'll say it's 5 to the negative 1, right? 5 to the negative 1 is 1 over 5, right? Now we can add the exponents. So n plus 1 minus 1 is equal to n. Okay? Let's see, we'll do this one. 2 to the n minus 2 to the n minus 1 divided by 2n. Okay, so we're going to do this, we can put the 2n in the numerator, so we can put 2 to the negative n, right? And then we multiply times 2 to the n minus 2 to the n minus 1. And then we multiply this times this, and we multiply this times this. 2 to the negative n times 2 to the n is 2 to the 0. 2 to the negative n times 2 to the n minus 1, you add the exponents, n minus 1, you get 2 to the minus 1. Okay, so we get 1 minus 2 to the negative 1, which is 1 half, negative 1 half, equals a half. Okay, and this is the last one here. We're going to multiply using the distributive property that we're going to distribute 2 to the n to each of these. And we're going to do the same thing here. Okay, and then we combine these two, we get 0. Combine these two, we get 2 and 2 to the n. And you notice that we're multiplying 2 times 2 to the n, so we could write that as n times 2 to the n plus 1. Okay?